Okay, so let me explain again, in case you forgot since last week, what we're building in our JavaScript hands-on lecture. We're going to be building a little game that eventually will display an array or a table of treasure cells, and it's going to be laid out as a matrix or as a table. And some percentage of these cells have a treasure in it, and you click on the cell. The game is finding the treasure. You click on the cells. Each time you click on a cell, if there's no treasure, it opens up. You see nothing in there. When you finally hit the treasure, your score gets computed based on how long it took you to find the treasure. So the game is seeded with 3 parameters: the number of rows, the number of columns, and the percentage of treasure cells. And once you have the percentage of treasure cells, if you know a little bit of statistics, you know that statistically the expected number of clicks to find the treasure is 1 over p. So 25% treasure cells means it should take you about 4 clicks to find it. Okay? So we're going to take the ceiling of this to make it a number, and if you find the cells in this many tries, your score is 0. Otherwise, the score becomes negative if you take more, and or a positive you actually take less. But the interesting part here will actually be building the game, not so much playing the game, as you can already see. Okay, so if you go to the lecture materials webpage, you'll find there's not much slides. In fact, I'm not going to use any slides today. We're going to all be building based on this JavaScript tutorial that you can get from there, and all the files. And I've expanded it a little bit since last week. So really, this should be something you could follow at home as well when you review this lecture. So I'm going to load treasure 1, 2, because we kind of looked a little bit at JavaScript at the end of last lecture. I want to go directly to treasure 1, 2. And remember that we're using, I've loaded this file. There's nothing shown in there because this file, as you will see, contains mostly JavaScript, which resulted in defining some functions, but nothing visible yet. So I'm going to open the inspector in Chrome. And here at the bottom, we see the inspector that we used before. For JavaScript, mostly we'll be using this sources. Should I increase it a little bit? Maybe like this. You'll see this sources panel, which is where most of JavaScript will live. For now, I'm going to close this right side pane panel so we can look at JavaScript. Okay, so let me walk you through a little JavaScript function, and this is the function that I wrote to generate the data structure for this treasure map. Not so much the visible part, but the internal data structure. And it's a function that takes 3 parameters, as I explained: number of rows, columns, and the fraction of treasures. And you're using the function keyword to define a function in JavaScript. And notice that the parameters do not have types. So this will look a little bit like Java, except there won't be types. You use the var keyword to define local variables. And I made a table. Okay, let me just a second here. So last time we drew this. This is part of the instructions that I wrote here. Last time we looked at all the various kinds of values that you can have in JavaScript, and so I have this table here summarizing them. This is the value type, but then again, this is not a type that appears in your program. This is an internal type that each value maintains, right? So this is it's a dynamically typed language. Values do have types. When you create the value, it has a type, a number or a string. This type is not declared in the program. That would be a statically typed program like Java. So JavaScript has numbers. In JavaScript, there's no distinction between integers and floating point. Everything is a floating point. So you use the usual notation for numbers. You have booleans with 2 particular values, true and false. and the usual operators, comparators, and such. Strings you can define in JavaScript using either double quote or single quote notation. And I'm not actually very good, you will see in my files, at being consistent which one I'm using, although you should really be consistent. Use all double quotes or use all single quotes. It makes it easier to read. Lists are defined using square brackets and comma-separated values for the list elements. And the most interesting value in JavaScript are the objects. And objects are defined using key colon value, comma-separated key colon values. The keys should really be strings, although notice that in JavaScript it's not very picky if you don't use the string notation. If you just use a key without quotes, it'll take it as the string key. The values can be any of these values, including objects, and this is how you create hierarchical structures. So you're using objects for many reasons in JavaScript. It's really the workhorse of data structures in JavaScript. In particular, you're using it as dictionary and hashes would be used in Python or Ruby, but you're also using them as objects, as in object-oriented programming, which we'll get to a little bit in a little bit. Okay. Any questions about values in JavaScript? No. Okay. So switching back to yes.
So I guess one thing with the objects, like if we're using it as an object, so I guess its key would be the function name, and then it's in. Like how does it work as an object?
You will. I will get to that. I will get to that in a little bit. Okay. Maybe actually in a minute. Okay, so I'm going to switch back to the actual JavaScript code that we're reading. So here we're initializing the treasure to a list. This is how you write the empty list. So let me explain the data structure that this game will use. Each cell has a coordinates. This is 0, 0, row 0, column 0. This is 0, 1, row 0, column 1. And each one, it's either a treasure or not. We're going to represent the data structure by having a list of the cells that contain treasure. Okay? So that's why I'm using a list here. And I'll explain a little bit what I put in that list. I will put an object. Each element of the list is an object with two keys, x and y, the coordinates. Okay? So we have a list of x and y coordinates. And as you might expect, you need a doubly nested loop here to scan this matrix and to place the treasures. And we're going to place the treasures using a random number generator. And this is the first, this is the built-in random number generator in JavaScript. And let me explain a little bit the notation here. Math really is an object. Okay? Dot is how you refer to fields of that object. And again, objects, dictionaries, the same thing. So you'd use dot to refer to the value in a dictionary as well. Math is a built-in object that has many functions like sine, cosine, and one of them is random. And so what really this says is take the math object, fetch the field called random, and invoke it. So the value of the field is going to be a function. Hence you can invoke it. We'll talk some more about functions in JavaScript. It's one of the most powerful concepts there. So rand treasure is going to be a number between 0 and 1, returned by the random number generator. And we need to make sure that about 30%, let's say, if fraction treasure is 30%, 0.3, if the random number generator returns something less than 0.3, which is roughly a 30% probability, then we place a treasure in the current cell. And then we do this repeatedly for all cells. How do we place a treasure? We construct an object first with two fields, x and y, being the current coordinates, and we add this object to the treasures list. So dot push is a method, or it's a field, if you want, of the treasures list, and its value is a function that kind of appends to the list. Any questions? Okay. So you really should take from this more the spirit of the language. Over time, you'll probably learn that dot push is how you append to list, but I always forget when I switch between Python and JavaScript and Java how exactly you append to list. So then that's when you look at the documentation. Just have a concept of what's possible. Okay, and this function then just returns the treasures. Okay, so now let me switch and show you a little bit of the debugger that comes built in most browsers. So there's two sides to the debugger. One, I already described the sources panel that allows you to view the JavaScript, but then the most important part is the console. The console is in this bottom pane here, and it gives you this prompt, and that's where you type JavaScript. You can type 1+1. Whatever you type, it reads it and executes it and prints the result. So you can use it as a little calculator. But more interestingly, you can type math, and it gives you essentially the math object, math.random. It's a function. So random is a field of the math object, and its value is a function, and doesn't show here the code. And then you can invoke it, math.random, like this. And it prints the result. And I press the up arrow, it recalls the history in the console, very useful thing. And you can call the random number generator several times. So this is, I use this a lot to kind of find my way. Maybe if I forgot exactly what random does, I can find it this way. A very useful feature here is the completion. Notice when I put the dot, I get this window with all of the functions that the math has. So that's another way you can find the functions that you need. And the completion works, you know, if you type the first few characters, then press tab. Okay, but so we use the console so far to explore the built-in functions. What about the function that we have just defined? Scrolling up here, it was called make treasure map. What happens when you write something like this? At the top level, so this is not inside some other JavaScript functions, really at the top level. JavaScript will parse this function, will create an internal representation of the function, and then it will define a new global name, essentially make treasure map, whose value is the function. And the console, the inspector, already knows this. So if I tap MA, it completes make treasure map. And I can actually call make treasure map. Let's say 4 rows, 5 columns, 0.3 is the percent of the treasure cells. And I can run it. Okay? So I can run the functions I've just defined, and notice it prints here the result. It's a list of whatever, in this case 8 objects. So it placed 8 treasures in this case. And the cool thing is that you can click all of these handles, and it expands the objects. You can see that the first object is 0, 0, and whatever, an object here in the middle, it's 2, 0. These are the coordinates of the treasures. Okay, one more thing that I want to explain here. You can put breakpoints. I can put a breakpoint, for example, here by clicking the line number 28. It places this marker, and now whenever this function gets executed, execution will stop there. So how do I execute this function? I want to show you how to stop at the breakpoint, so I want to execute the function. How do I execute this function?
I'll make treasure map.
Right, using the console for now. Okay? As we evolve this application, there will be ways in which this function will be called automatically when you start the game. But for now, we haven't written that code, so I call it from the console. And notice that the execution has stopped. It's paused in the debugger. And what I want to show is now this right panel here has several useful things. One is the call stack. It tells you where you are and who called you and so on. And this is going to be very useful for you to debug your own function. There's a local panel here that shows you the values of the local variables, and in Chrome those are also shown here in the code window for your convenience. Okay? And the breakpoints that you have, and a lot of other cool stuff as well. Okay, and one thing you can do, and we will do this quite a bit, as you debug your code, you can use the console to actually run functions in the current context of where the execution has stopped. Okay, this is powerful. So if I type here, for example, rand treasure, it knows it has value 0.214. Furthermore, I can try to run some code. For example, I copied this conditional. You could copy and paste. Okay, so you're stopped in the debugger, and you can do what ifs. What if at this point I were to run this? What if I were to explore this? So it's really very powerful. It's more powerful than most debuggers I know. For example, in Java, if you were to do this, you can't typically run commands in the Java debugger. Do you know what may enable JavaScript to have this feature, but Java to not have this feature? I want more of you to think about this.
Sorry, what feature? Breakpoint?
At the breakpoint, I can run arbitrary code. I can compile and run arbitrary code.
Because JavaScript is dynamic, the code is dynamically generated, kind of?
Kind of, yeah. So let's say somebody else you're very close. Yes?
JavaScript is compiled line by line, where all Java is done all in one piece.
Almost. So you're getting very close.
JavaScript is interpreted.
JavaScript is interpreted. So that's really the closest to truth answer, but you all have the same idea. So Java programs are compiled. You have to invoke a compiler, which is a pretty big beast. The compiler has to have a lot of context to be able to compile any single line of code. Okay? And I guess one could build a debugger that as you type in the debugger, it fires the compiler, creates new Java classes, and runs them. That may be possible, but it's actually quite hard. In JavaScript, instead, by default, JavaScript is interpreted. So every line is taken, it's parsed. You know, if you've taken the compiler class, you learn what that means, and it's executed. And then it moves on to the next line. So that's the default JavaScript execution. In truth, all browsers nowadays, if you run in real mode, not in the debugger, they will actually compile your JavaScript so that it's faster. But JavaScript really supports both interpreted line by line and compiled. Now, the interpreted execution mode comes very natural here because I type a line, it parses it, it executes it. So it's really playing to the advantage of the interpreter, this kind of debugger.
Why in Android Studio then can you highlight a line of Java and evaluate just that line? Is it doing some sort of?
It's running an interpreter.
Oh, okay.
It's built. It's a feature that they built in. But I suspect you can't quite. There might be limitations to what you can do there.
Okay.
Here there are no limitations. I can copy and paste this entire code in here, and it'll run. Okay. Moving along. I'll turn off the debugger and then press this blue arrow here to resume execution, and scroll at the bottom. This time it placed 4 treasures. This is the last execution we had. Okay. So I'm now ready to move on to the next stage of the demo. Treasure 1, 3. Now we're starting to see some object orientation here. Again, there's nothing shown in the HTML window because we haven't written the code to show anything. But I want to show you how I've changed the code in this version. First, I changed the name. It's not make treasure map. I named it treasure map with a capital letter. This is more of a convention. Bless you. This is more a convention than anything else. The idea is that we're going to make this akin to a class. And we're going to be creating treasure maps using new keyword as opposed to using our make treasure map. But really, inside, it's all the same thing. The difference is at the end, I'm using this special keyword this to refer to the current object. Okay, so here's what's going on. I'm going to invoke this function in a different way. I'm going to write, well, let's give it a name, the map equal new treasure map 450.3. Same parameters as before. So notice the new keyword new. So this means construct an object. Next, after new, is really what's called a prototype. But you can think of it like a class. But if you look at the code for treasure map, it's just a function. Okay, so any function in JavaScript can be a class, really. It's kind of strange. But in truth, when you write these functions, you use certain naming conventions to kind of help your readers understand that this is meant to be used as a class, not as a regular function. And there's one notable feature of functions used as constructors or invoked with new is this refers to the object being constructed. Okay, so what's going to happen is new is going to create initially an empty object, and it's going to invoke this function treasure map, setting this to that object. As the function executes, notice that it computes this treasure local variable, and then it makes it a field of the object by setting this.treasures equal the local variable treasures. Okay? Is that clear? Or maybe not too confusing? Okay, so object-oriented programming in JavaScript is different than, in some ways, than object-oriented programming in Java or Ruby or other languages. And we're not going to get into the details of technically exactly what's different. I'm going to show you mostly through examples, but it's actually fairly easy to use. So if I run this code, the map, it shows that it has created something that is obtained from treasure map. So this is again like the name of the class, and I can expand it, and it has the field treasures, which we have set just above. So this line in the code sets the treasure field, and notice that the object that's returned has the treasure field. You also notice this proto field, and this is what makes this object really more like an object-oriented object. Okay, so this tells the object to which class it belongs. Although technically, treasure map is not a class; it's called a prototype. Let's not get into that just now. Okay, any questions? Okay, yes.
What is the difference if we don't invoke the word new?
If you don't invoke the word new, you can do that. Treasure map 450.3. It doesn't return anything because we don't have a return statement in this function.
But if
Okay?
we have it, the variable for it, it will be the same thing, right? Let's say the map2 and then treasure map.
No, the map2 will be undefined.
So, but it will have the same object. Right?
No.
Oh.
No, because you have to use the treasure map is just a constructor. Does not allocate an object. Does not create an object. It's new that creates the object. So new treasure map says create an object and call this constructor to finish filling it in. Okay. Here you just call treasure map, but you didn't give it an object.
Can you set a breakpoint at that this dot treasures and then run the treasure map without new?
And why do you say that?
Because I want to know like what this is.
That's a very, very, very good thing to try to know. So he wants to see what this is.
Oh, okay.
Okay?
Okay.
What do you understand from that?
That's the global scope.
Yeah. Okay, so maybe this is more than I wanted to show you. If you invoke a constructor without a new keyword, the constructor runs. And actually it turns out that this always has a meaning. If you call it with new, this points to the object you've just constructed, so the constructor gets to fill in fields. But by default, this actually points to the global scope of JavaScript. So the treasures field, it will be set as a global variable. Not what you wanted, really. But something happens. Okay, this is if you want the downside of these dynamically typed languages. They try very hard to run, even if you write garbage in there, and will do something, and it might not be what you expected. So, one observation I want to make here, and thank you for your question. You will be using very complex technologies, browsers, Django, Rails, that try to help you by doing lots of stuff under the hood. Okay? In my mind, what makes the difference between amateurs who kind of pick this up in their spare time and professionals, which are trained to be, is that professionals try to understand what actually happens under the hood. That's why we teach you the algorithms class, the networking class, the operating system class, the database class. We don't just teach you the SQL language and the Unix commands. We teach you what happens under the hood. Okay? So you should train yourself to always inquire, what's going on? Why does it work? Okay? What happens if you don't do it like this? It could be an error or something runs. Okay? So always try to look under the hood. I will put the premium on this, especially, again, as you will use, so Rails even more than Django. Rails seems to do magic for you. Write a command and it generates hundreds of lines of code for you, okay? You could just go on and write your hello world, ignoring what Rails has done for you. But I promise you, there will come a time when you'll need to debug some aspect of your application, whether it be a security or scalability issue or some other behavior that you don't understand, where you'll actually need to go down deep and find out what happens. So you should never allow yourself to kind of use these tools without understanding what goes on. And you should especially be scared if it seems like magic. If it seems that the computer program has done magic for you, okay, you're in for a disappointment sooner or later, because there's no magic there. You'll have to understand it. Okay, thank you. Moving along. It's time now to start putting things on the web page. So I showed you how to write JavaScript, how to execute it, but how do you connect it with the actual HTML to show things on the screen? So for that, I'm going to load the Treasure 14. And Treasure 14, let me close this right pane and increase a little bit the JavaScript window. I want to draw your attention to this, oh sorry, that's not 14, 13. I just, so same document as before. I wanted to show you how JavaScript ties with the actual web page. And I'm going to do that by using this watch feature of the debugger. Watch is, the user can configure in there variables or expressions that the debugger will show whenever it stops. And I'm going to use this name called document. Document is a special name in JavaScript, and it refers to the root of the tree data structure that describes the web page, the currently displayed web page. Remember when we discussed HTML, we said that HTML is a hierarchical structure with body, div, nested divs, and so on. Okay, There's more to it. There's also style, CSS, and so on. All of these can be accessed from JavaScript using the name document, the global name document. And I put it in the debugger because that's the best way to look at it. So let's look at document. Document has many fields. Look at it. All of these are fields of the document object. But document is only, well, let's look at some fields here. One field is content type. What kind of content type is this document? It's HTML, character set, all of the applets loaded on the page. But the one that I want to draw your attention to is this child nodes. So I said this is a tree. The way it's represented is there are nodes that have many attributes, but one special attribute called child nodes, and that points to the children. So the document has 3 children. If I expand this, I see that the first children is the doc type HTML, next is a comment, and then is the HTML. We can switch back to this window and see indeed that this is the first node, this is the second node, and this is the third top level node in the file. Now the HTML itself has its own children, right? But this kind of spans from here to the end of the file. And you can expand like this. I expanded HTML and I see that it has 3 children. There's a head, there's a text, and a body. And I can expand the head, and the head has 7 children. Has a text, a title. Okay, switching back to the left window again, we see that the head has a title, has a style. This is here. So you may wonder, what are these text children? Because you don't see them here. Well, it turns out that after title and before style, there's a new line. The browser really takes that and makes that a text node with the new line content. So it really represents everything you've written on the page. Any questions about the document? You have a question? Okay, probably not. Yes?
Wait, how did you get to the watch expression? To make it show document?
How did I expand this?
Or how did you get the...
So first, I was looking at the document variable.
How did you get the document?
Okay.
How did you get to the window?
Oh, this window?
Yeah, let's see.
It's by default it's there, but normally most often I hide it clicking this and then unhide it clicking this handle here. Was that the question?
No, like how did you...
Okay, so then, let me explain what I did. So this is how the window displays, but when you open the debugger, normally this should be displayed. Then I wanted to inspect the document variable. There are many ways to do that. One is, if you're stopped at the breakpoint, you can go in scope locals, as we've done with the other variables. But another way to do it is to add a watch variable. So I went in here, I pressed plus in this watch panel, and I typed in document. And this adds a watch for the document variable. And then I keep expanding its children until, and so on. Okay, does this answer your question? Okay. Good. Other questions? No more questions. Okay, but let me, so far I showed you how to inspect the document, and this should already give you an idea. Because document is a variable known to JavaScript, you can write JavaScript code that uses document to traverse and find out what's on the page. So that's how JavaScript gets information from the page. How does JavaScript put information on the page, change the page? So also using the document variable. So for example, if I type document in the console, there's many methods a document has. One that I'm going to show you here is get elements by tag name. This function, or this method of the document object, takes a tag name, and I'm going to say body, and returns an actual handle to the elements on the page with that tag name. Okay, so if I wrote a div here, it would return a list of all of the divs on the page. Right now, there's nothing on the page, so that's why I'm using body. It's the only element that has a tag there. Notice it returns a list with one element. And what can you do with it? Well, one thing, I'm going to press up arrow and recalls the last command. I put dot inner HTML and I put hello. Okay? So what I'm doing is, get elements by tag name is a list. So before I do this, I want to get the first list element. So using square brackets, you can index into lists with, and I can test that. Yes. So before it was a list, now it's just one element, body. And now I can set the contents of this element. And now you should see, thank you. I would have spent a little bit here. Okay, so this is the whole purpose of this experiment was to show something on the page. So the error that I had before, I misspelled HTML. This being a dynamically typed language said, oh, you want to set this, this field onto the body, we'll set it. But this field, it's stored there with the body object, but it's not interpreted by the HTML renderer. It has to be inner HTML. And then once you do this, the HTML renderer that constantly watches what's going on with your document object will update the web page. There was a question.
Oh, just answer it.
Okay. Okay, so this gives you an idea how JavaScript can read contents of the web page and can change contents of the web page. And from here, you can do lots of things. You can validate stuff on the web page. You can update the web page. You can even change completely the web page looks. The only problem at this point is that this is kind of an ugly way to be programming, and we will introduce a library that will make this a lot faster. But first, we need to take a break, if I'm correct. Yes. So in this break, I will show you, as usual, a puzzle. And this is from an actual interview. But you should also really take a couple of minutes break as well, while your brain is decide as a team is what platform you're going to be using to build your project, whether Rails or Django or perhaps Node.js. The reason that is important is that every member of the team, when doing part 3 of the individual project, the Smile, it will have to be done in the same framework that will be used for the main project. Okay, so if your team decides Django, all of you have to do Smile, part 3 of Smile in Django. And that kind of starts in maybe 10 days, so you have a week to decide that. But of course, in addition to that, you have to start really fleshing down what the project will be. Okay, the proposal is just the starting point to get you together. Okay? All of you should be excited about that kind of stuff. Now, what the details are, it's for the team to work out. Any questions? Yes.
I have a question about the first part of the Smile thing. Is that supposed to be like identical to what the pictures look like, or are we just supposed to do the same kind of things?
Try to stay very close. It's not automatically graded, that is pixel by pixel, but take that as a specification. Somebody gave you, this is how it has to look. Okay? Really, we're only going to be seeing the end result, not the individual tasks. Okay? So, but the end result should be the same.
How do you know whose GitHub is associated with who?
Yes, we will. There will be a form before Friday where you can submit the GitHub URL. Okay, so you submit to push to GitHub, and you'll have to submit this form. Okay, some more questions? Yes.
Where do we find the selected proposals that we're linking?
There should be a link. If you go to the projects assignments. Project assignments.
Okay, I found it.
Okay. Yes, please use this form, and the form should have the link. Is that? Because half of you already submitted those preferences. Okay. Okay. Let's switch back to. Anybody wants to take a stab at this? I want to first see how many of you have thought about this. Okay. Even that counts as a great hand. Okay. So in the back, there were glasses. Yes.
I would say it's 2/3.
2/3. Why?
Because there are 6 different laws, each of which are equally likely to be chosen. Of those, 3 of those are white. So there's no use taking one of those 3. And of those, 2 of them have white as the other column.
Okay. Other answers? Yes.
50%.
Why?
Because you've already picked one white ball, so then you're not in the double black ball bag. So it's either the other ball's either white or it's black, depending on which bag you're in.
Okay, that's answer number 2. And other answers? No. Let's try to vote. Who thinks answer number 1, 2/3, is the correct answer? 20. Who thinks 50%? A little bit less. And there's still a bunch of you who haven't raised their hand. So the correct answer is 2/3. Because it's true that once you pick, there's still 2 choices. But it's a lot more likely that you would have picked the bag with 2 white balls than the other one. So even though it may seem that now you have 2 choices, one of the choices is more likely to happen because I know you're saying I'm gonna go home and get 6 balls and try it.
Well, I mean, it's saying given that we've already picked the first white ball though. So originally it was 2/3, but now that we've picked the first white ball, doesn't our probability change for the next ball to be 50%?
It does, but it changes to be 2/3. No, it's 2/3. In the back. Can I explain it one more time? Okay, we're getting into.
Okay, makes sense. I don't know.
Okay, I think the explanation was actually very good. There's 6 balls, equally likely. So you picked a white one, but there's 3 ways to pick that white one. You pick the white one that's alone in a bag. You pick the first white ball in the bag with 2 white balls. You pick the second white ball in the bag with 2 white balls. Okay. Looking at this context, okay, 2 of those 3 outcomes, the second ball is white. So it's 2 out of 3. It's 2/3. But this is something you can really try with a few balls. And this did come up in an interview at Conviva. It wasn't my question, it was one of my colleagues. Okay. Let's... So at this point, let me... Works, okay. So where are we? We've learned JavaScript. We're all experts in JavaScript, right? And now we're making the connection between JavaScript and the browser. Because JavaScript is a powerful programming language, but Java also is a powerful programming language. What makes JavaScript truly widely used is this tight connections it has with the page. Okay? The fact that it can read and write to the page. It can make changes to the page. So that's where really we'll be spending most of the time from now on. Not in programming additions in JavaScript, but tying it in with the web page. And I've shown you this kind of ugly line just to put the hello on the page. So people have seen that, and they have built libraries that make this a lot faster and easier. So that's first shown in Treasure 1.4. If I load Treasure 1.4, still nothing shows on the page. But if I look at the source, the one thing I've added to the source is this line. This is still in the head. It's adding a JavaScript script. Can somebody please close the door in the back? Thank you. This is a different kind of JavaScript. Notice this script tag. It starts here, contains JavaScript, and ends somewhere else. This is a way of actually inserting JavaScript inline into HTML. Another way of adding JavaScript to HTML is to just refer to the URL where the JavaScript file can be fetched. And I've added this jquery.min.js. This is the Jquery library. This is the source file for the Jquery library. Let me show you to you. I go to sources now, and you will see here two sources. There's JavaScript in treasure14 the one we've seen, and there's this jquery.min.js. And what you can see a comment that's nicely readable. It's jQuery version 2.1.3, and then you see 3 more lines or unintelligible. Well, it's JavaScript. Believe me, this is JavaScript. It's not meant to be read. Okay? This is how JavaScript is often distributed. So jQuery is a big project. It has hundreds of functions that it defines in tens of files. What they've done, once they're done testing it, they concatenate all of those files and they run them through something called a minifier. Hence the name .min. Okay? The minifier will rename all variables and function names to have very short names to reduce the size. And reducing the size means this file is loaded faster, your web page appears faster. Okay? And it removed all the new lines, all the space, all the comments. Some people use minifiers as a way to obfuscate the code as well. Okay? Since JavaScript is distributed in source form, essentially, it's given to the browser to execute in source form. If you have something there you don't want people to copy easily, then you can use a minifier, and it's going to show like this, and it's very hard to actually make sense of it. But it runs just fine. Any questions about the minifiers? Okay. You don't have to use minifiers for your project. And actually, I rarely do myself. Okay, let me show you what this Jquery library does. It does actually quite a few things. If you I went here and navigated to jquery.com, and if you click on API documentation, you can just scroll down to get a sense of the number of functions that jQuery provides. Okay? All of this is functions that would help you write code. I use a very small number of them in any given project. Okay? But there's one function that's truly very, very important. It's a cornerstone of jQuery. And the function has the name $. So if you press $, is a valid identifier name in JavaScript, and jQuery, kind of monopolized it. Whenever you see $, typically is jQuery or an extension of jQuery. And one of the things that I do with $, I invoke it, giving it a selector. Okay? So remember when we discussed CSS selectors, you remember that the selector body refers to the HTML elements with the tag name body. And we know there's one of those. So this $ function, if you give it a selector, it will return the list of all elements on the page that match that selector. So if I press $body, notice I get the list with one element. This is the same so far at document.getElements by tag name body so far. But it can do a lot more, as we'll see shortly, in the sense that we can use here instead of body any CSS selector that we learn, even the complex ones with classes, with IDs, with descendants, and that's going to come in very handy. But on top of that, jQuery gives you a lot of helper methods to operate on these elements you selected. And one of them is HTML. So the HTML function, if I invoke it like this, without any arguments, what it does, it first it scans the document, finds all of the matching elements. There's one of them. HTML with no arguments, it extracts the HTML of the body element, and it's the empty string, actually a space. There's nothing there. And if you give it an argument, I call it again with an argument hello, then it changes the HTML. Okay? So this is the jQuery way of changing the web page. First, you do $, then you put a selector to identify what elements of the web page you want to update, and then you call .html, and you put the stuff, and this stuff will be put in all of those documents. Okay. Furthermore, and again, it's important, $ in jQuery returns a list of all of the matching elements. So you can, with one line, operate on a set of elements. It's very important. The other thing that's important to remember in jQuery is that all of these helper functions return the same list of elements on which it was operating. Okay? So after you set the HTML, notice that it returns the body, which now has hello. This allows you to chain functions. So I can write .css color red. So .css adds a style attribute to all of the matching elements. And in this case, we're adding the style attribute color with the value red. And notice how hello has turned red. And in fact, if you were to now look in the inspector at the elements, you will notice that the body element has an inline style color red and an inner HTML hello. Okay, so this was all added through JavaScript using the Jquery library. Okay, and other questions? Okay, so Jquery really helps, gives you all of these helper functions to do things cleanly. Trying to write this in pure JavaScript using the document, it's kind of messy because you have to have a list that scans over all of these, set the inner HTML, and then for all of those, set the style attributes and so on. So, okay. This was a quick intro to jQuery. You'll learn more of jQuery as we actually start using it to build our treasure game. So far, we have we've looked at the simple JavaScript function just to learn how JavaScript looks, what kind of values you have, and that JavaScript function was building the data structure for our treasure map. We introduced jQuery as a way to operate on the DOM. Now we're ready to actually start developing our game. So I'm going to move to treasure 1.5. And this time we start to have some HTML. Okay. So this file actually contains a. We can see it here in the debugger. It contains an H1, which gives you the heading, contains some text, and the way this is intended to be used is this question mark will be filled in with the percentage of treasure cells. So once we generate the treasure map, that's going to say about 30% of treasure cells have contain treasures, which means that you should expect to take, and this is our computation of what's the expected number of attempts to find it. Okay, so far the HTML contains those placeholders. The way I put those placeholders in there is actually in a way that will allow me to later update those numbers. So I created two elements of type span. So notice the code here. This is the first one, and this is the second one. And I gave them IDs. This has ID the %, and this has ID the expected. I gave them IDs because I'm going to use JavaScript to refer to them and update their contents. And I'm going to do it like this. $. Now I have to refer, well, let's do something simple. Span. What should this return? So, can you say loud? Yes, it's gonna search for all of the elements of type span, and there's 2 of them, and you can verify that it returns a list of 2 elements. So if you do .span.html15, what's going to happen?
Change all these non-content.
Okay, so all of the spans will be changed to 15. Press enter. Notice how the page has been updated. Okay, this is in case you want to change them all. And somebody else, how am I going to change only the first one? This %. Right, I have to change the selector, hashtag the %. And let me change it to 25 so that we can see the change. Okay, so hashtag span hashtag the % means find all spans with ID the %. And we can verify that it's a list of 1 element. You can even do just this, the %, without saying is a hash span. What about this? Body space the %. What will this return? Do you remember what the space means in a selector? Descendants. Descendants is more accurate. Anywhere in the children or the children of the children. So take the body, and anywhere inside the body, anything that has ID the %. Okay? So it's going to be the same thing. Okay? All different ways to mark it. Okay, so let's move on now. I want to now actually write some code that renders this information automatically, as opposed to me putting in this 15 or 25. So that's already in version 1.6 of the file. So I load version 1.6. Initially it looks the same, but let's look at the code. So I click sources. In sources treasure, let me close that. Okay. Okay, so I have this class treasure map, same as before. During construction, it constructs the treasure data structure and sets the treasures field. Then I added code to compute the expected attempts. So it's 1 over fraction treasure, and you compute the seal of that. So that's another function in the math object. And then I'm starting to add methods. Yes, there was a question in the back? No? I'm starting to add methods to this object. Notice I'm using the same syntax for setting a field, because methods and fields are actually very related in JavaScript. So this dot render equals function. So the way to read this is that this sets the render field of the object to this value. Well, this value is a function that takes no arguments and does something. Okay, so this is one way to set methods in JavaScript. And I'm using jQuery here to say, find the %, the object with the ID, the element with the ID the %. That's going to be the green question marks there, and set the HTML to 100 times fraction treasure, which is the treasure of the fraction of the treasure cells, and set the expected to this expected attempts, which we have computed above. I want to take a minute to point some things out here. One of the most powerful features of JavaScript as a language is this what's called higher order functions. We can define functions as values. Okay, this is different from languages like early versions of Java or C and C++, where functions have to be defined essentially in classes statically. This is a function that's constructed at runtime. When the execution gets here, it constructs this function. These functions can refer to values that are in scope. So fraction treasure is in scope because this entire code is inside the constructor that takes fraction treasure as an argument. Here. So this makes fraction treasure available in the whole body of the constructor, including here, here, and here. And same, expected attempts. JavaScript is going to find it as this variable, expected attempts there. Okay? So this is what's called a closure. It's a function that's defined at runtime, and it has references to the enclosing environment for the variables that it needs. Okay? This is really, really very, very powerful in JavaScript. But so far, I've just defined a function. I haven't actually invoked it. So let's try. So first, I'm going to construct the treasure map using the constructor as we've seen before. Let's say 4.5, this time 20% treasures. This is going to construct the object. And now I'm going to call the render treasure map method of this object. So I write the map dot render treasure map. No arguments. I don't need to pass arguments to render treasure map because render treasure map is a closure. It has references to the actual values of the fraction treasure and expected attempts. So if I run this, what should I see? So I should see the effect of these statements. We should change this question mark. What should be here? 20. And here? 5. Okay, so if it's correct, yes, it worked. 20% and 5. The colors did not change because the colors are set through CSS. I just changed the content, the HTML. Okay, so this is how we're starting to run this. What I want to do next is show, yes, question.
If you had defined render treasure map without doing that thing where you said it, if you had said function render treasure map like the regular way, and then you ran it, would it be different?
If I define function render treasure map, it would define that function, but it would not make it a field of the map. So I would have no way to refer to it from here. It would be a function defined inside the constructor, only visible inside the constructor. I cannot call it from outside directly.
So you're saying you have to do it this way in order to do it in an instance?
Yes. Okay. This is how it sets a field. There's other ways to do it in JavaScript, but this is one way. Okay. So I want to show you next how to actually run code when the page loads, because we want this game to actually start on page load. So the first attempt is treasure17, which I'm going to run. Same template at the top. If I look at the code, what I've done, after defining my constructor, I wrote simply the code that I used to type in the console. The map equals new treasure map, and then the map.render treasure map. The idea is that when you load JavaScript in the browser, it gets executed right away as the page loads. And the first part of the JavaScript will define the constructor, and then these will get executed. So, yet, when I loaded the file, notice nothing has changed. So something is wrong here. I added code to construct the treasure map and render it, but the rendering doesn't show. And the first time you encounter this, it's really something that puzzles you. You put a breakpoint at the beginning of that line because you think maybe the execution doesn't get there. I refresh the page, and the execution stops there. Well, I actually put a breakpoint inside here, inside the render treasure map, and say maybe it doesn't get there. And I continue the execution gets there. So these lines actually do get executed, but nothing happens on the page. Some of you, I'm sure, know the answer. But this is something that all of you should know. And the way I'm going to debug it next, I'm going to see, let's see, what is this the percent? So I'm using the JavaScript notation in the console, and I run it, and I get the empty list. So essentially, jQuery cannot find anything with ID the percent in the HTML. And it's the empty list. And jQuery, this is the other thing it does. I told you, this constructs a list. This applies the HTML function to everything in the list. If the function is empty, this is going to do nothing, no error, just moves on silently. What happens is this JavaScript does get executed, but it's before the browser managed to actually render the HTML. So the span elements don't actually exist yet. If I let it run, it finishes running the JavaScript, and then it renders the HTML. I'm not going to go into details, the order in which the browser renders things. In fact, you should not write code that depends on that, because it's a little bit, it tries to do things in parallel. It doesn't give you any guarantees that this is going to be happening before or after the JavaScript. So jQuery comes with a solution here. And I'm going to show you Treasure 1.8, which is the jQuery way of getting things to run once the page loaded. So notice that indeed the page got updated. And looking at the code, instead of putting this code, this initialization code at the top level, I wrote this thing, $document. This is a jQuery way of taking the document variable, which really is the root of the whole HTML tree, and this makes a jQuery object out of it, ready, and a function. What this does, it says, run this function when the document is ready. It won't run it right away as it comes through here. It'll remember the function. And once the browser says, okay, everything is ready now, initialize the document, the CSS, the JavaScript, now this function gets run once. So this is the proper way to start your application in JavaScript, using .document.ready. And now you can put breakpoints, and you see that indeed the execution now happens after those spans are rendered, and jQuery can get to them and can update them. Okay? Yet another example of using higher order functions here. Okay? You'll use this a lot in JavaScript. You'll be defining functions and passing them on to other functions. This ready function will actually remember your initializer, store it until the web page is loaded, and will execute it at that point. Okay, you'll do this a lot in JavaScript. Okay, I have 5 more minutes actually to do quite a bit. Actually, 2 more things that we need to do. One is in Treasure 1.9. This is the actually rendering of the treasure cells. So notice they actually appeared there. So how did I do this? Let's look at the code. There's multiple ways to render stuff in HTML. But the way I've done it, I've expanded this function render treasure map. Before it had just these 2 lines that filled in the spans. I've added code to it. And what I've done is this function constructs an HTML string for a table. So it starts with a table. It keeps appending, so plus equal, it's how you concatenate strings. It adds, for every row, it adds a tr element. And if you know HTML, this is how you construct tables. Table, for every row, there's a tr element. Inside the tr element, for every cell, there's a td element. Okay? The little trick that I'm using here, actually, I'm not going to get to finish this, and instead of making a mess out of it, I'll stop a few minutes early, and we'll continue from here next time. Okay? So today and tomorrow we have discussion sections where you'll be doing JavaScript, and next time we continue to finish JavaScript and then move on to the actual backend. Thank you.